Okay, this is the page 14 for the electroscope lab, kind of like a post-lab analysis, whatever you want to call it. It doesn't really have much to do with the lab. But, the first question asks, charge a plastic comb or plastic ruler with cloth or whatever, and use a charge balloon to determine the plastic object's charge. Explain your thought process. So, what do we know? What do we know for sure? Well, we know the balloon, and this is from the last problem, right? So this is kind of like an assumed thing. I'm sorry, my chair. I got a small room, so I got to deal with what I have. If I have my balloon, first of all, hopefully you try this on your own first. The point of this is to learn, not to really copy. If I have a balloon, and this has what? A negative charge. This is kind of what we know. It for sure has a negative charge. What else do we know? Well, we know we can kind of assume we did a good job charging it. The plastic comb is not going to be neutral, right? We charged it with something, right? That's in the problem. So it's got to be something. Now, this is pretty simple. Really, you don't have to overcomplicate this too much. If you bring it close and it repels, it's got to be negative, right? Like charges repel. But if it starts being attracted, it's got to be positively charged, right? If not neutral, for whatever reason. It shouldn't be neutral because we charged it, but I wouldn't write that down, right? If we really wanted to determine if it was positive or neutral, if it got attracted, because remember, negatives and neutrals attract. So we would have to have another object, but we're assuming this is charged of something. Okay, if you had a metal sphere that gained electrons, draw how the charges would sit on your sphere, explain your diagram. So if I had my little sphere, really all the electrons would kind of be, they're kind of everywhere, equally distributed, if you will, whatever. They're going to be everywhere, right? Because I just dropped this, by the way, but yeah. The electrons are in a conductor, a metal sphere, and they're allowed to flow around. So they're allowed to flow around, they will, I guess. Yeah, they'll flow around. Okay. Watch the following website. Go to the following website. If you didn't watch the video, watch the video. I'll summarize it though. Basically, like she's in her car. I'm not gonna draw it. It's gonna take way too much time. I don't want to use my art skills that much. She basically gets out of the car, puts in the little gas nozzle thing. She goes back in, and I don't know what she does. I actually have a chair. Oh no, wait, it's like jammed. Let me just unjam this. She basically, I don't know if you can see the seat, but she gets in her car, sits down, gets something, I don't know, gets back up, and when she's up and touches a little fire thingy, there's a big spark. There's a big spark. So what happened, right? What happened when she went back into the car after the gas was in, and then she came out? What happened? Well, she gained some sort of electric charge, and what probably happened, and I'm just looking at my answer, make sure I wrote this, is that when she came to sat down, her body rubbed with the seat, and when things rub, charge can transfer between them. So, boom, bada bing. Likely what happened was charging by friction occurred. That's like what the blank is, and she gained some sort of charge. Now, the next question: do you think that she has leather or cloth seats in her car? Explain your reasoning using electrostatics. And this one's pretty intuitive. You can probably imagine it is going to be cloth. Why? Well, the cloth kind of has this fuzziness to it, and when you rub with cloth, that fuzziness allows better transfer of electrons between the two. So leather doesn't have that kind of fuzziness, and there's a whole I think there's a tribal electric series, and you can figure out cloth does a better job of transferring electrons compared when rubbed compared to this. That's a whole thing you can get into. So what if she developed a charge by negative 15 nanocoulombs? What is the charge of the seats? It's got to be positive 15, right? So conservation of charge. Both were neutral to begin with. So if she got negative 15, for the total to equal 0, the seats better have positive 15, kind of deal. After you got back in and out of the car, describe something she could have done to prevent the spark. What she could have done is touch something metal, right? If you touch something metal, and if you have a positive charge, or whatever charge, she has a negative, doesn't matter. If you have any kind of charge and you touch metal, your hand is going to allow the transfer of electrons. If I'm negative, and I don't want those negative charges there on me, I just need to touch metal, and it will leave that, it'll leave. The charges will leave, right? Because they want to equilibrate. I shouldn't be touching something like a insulator. Now, you could try touching an insulator. It could work, but depending on the insulator, maybe it's, I know we haven't gotten to circuits yet, so I'm going to test my waters with my terminology. Depending on its resistivity and its resistance to allow electrons to flow through. Depending on that kind of thing, it might not discharge. Metal is a go-to, like just touch metal. Example would be like a doorknob or something like that. That's a daily example. This could be seen as charged by contact, right? You're touching and then charge it, you can discharge yourself. Could also be considered grounding. I wrote contact because that just, you're touching something, contact makes sense. But this is also known as grounding. You're grounding yourself. You could literally touch the ground to ground yourself. Ground yourself just means make yourself neutral, really. That's how I see it. So yeah, that's page 14 for you there. Let me know if you have any questions.